Microeconomics is a study of individual behavior. Billions of individuals have millions and billions of demand curves shifting around in their heads. Millions of firms have supply curves for the products they sell. Microeconomics and mathematics are foundations of macroeconomics, especially in my class. Macroeconomics is a study of aggregate behavior. There's only one demand curve because in macro we combine all demand curves into one, which we call the aggregate demand curve. There's only one supply curve because in macro we combine all supply curves into one, which we call the aggregate supply curve. A demand curve shows the quantity of a good that consumers will purchase at alternative prices, holding it all else constant. A demand curve can be referred to as demand. Quantity demanded is the amount of a good consumers will purchase at a given price, holding all else constant. Quantity demand corresponds to a point on a demand curve. A movement along a demand curve is a change in quantity demanded that occurs when its price changes, holding everything else constant. The law of demand is the economic principle that says that the lower price a good, the larger quantity consumers wish to purchase, holding everything else constant. Now this is a theory, so how do we test it? Well, like any theory in science, it's tested with an experiment. And the kind of experiment we're going to conduct here is we're going to ask some questions and then observe people's answers. So we're going to ask questions like, how many Big Macs will you buy per week when the price is $10.10? How many Big Macs will you buy per week when the price is 10 cents? So individual 1 will buy 0 when the price is high. When the price is low, the individual buys 15. Now individual 2 is a little different than individual 1. They'll buy 1 when the price is high. They'll buy 10 when the price is low. Individual 3 will buy none when the price is high, and only 2 when the price is low. Well, maybe individual 3 is a person that doesn't like eating meat, right? And so they'll buy 2 when the price is extremely low. I mean, why not? You can strip the beef off the Big Mac and have just bread, special sauce, lettuce, pickles on a sesame seed bun, and cheese. So yada yada yada, etc., 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 etc. So we have 11 individual demand curves in this market. Now we're going to aggregate these 11 individual demand curves up to the market level. And the way we do that is at the higher price we sum up the quantities that are demanded by the individuals in this market, and they sum up to 12. We do the same thing when the price is 10 cents, 112. So the market demand curve is represented by this last row, and then we have 11 individual demand curves in this market. According to our data, when the price is 10 cents, the quantity demanded was 112. So we plot that point. Now when the price is higher, quantity demanded is 12 Big Macs. Now we can fit a line to these 2 points using this point slope equation. We need a point and we got 2 of them, and then we need a slope. The slope is the rise, in this case, minus $10 over the run, which in this case is 100 Big Macs. So the slope again is the rise over run. Notice that when the price is 10 cents, 112 Big Macs are consumed in this market. When the price is $10.10, 12 Big Macs is consumed in this market. So we have a price drop of $10 and an increase in quantity demanded of $100 or 100 Big Macs. So the slope is a negative 0.1. The point slope again uses a point. We picked this as our point. We could have picked the other point, and that is our slope. We plug that in the point slope equation, right? Remember that when the price is 10 cents, we purchase as a group in this market 112 Big Macs. The slope is negative 0.1. We use a distributive property. A negative 0.1 times Q is a negative 0.1 Q. Negative 0.1 times a negative 112 is a positive 11.2. Now we add 0.1 to both sides, and we get the demand curve, which is negative 0.1 Q plus 11.3. We call this the equation for the demand curve. Now we want to figure out if we did the math right. So we're going to answer this question. Does the price equal $10.10 if quantity demanded is 12, if that's plugged into the above equation? And sure enough, 12 times 0.1 is 1.2. 11.3 minus 11.2 or 1.2 is $10.10. Plot the point. So far so good. We ask another question. Does the price equal 10 cents if 112 is plugged into the above equation? And sure enough, 0.1 times 112 is 11.2. 11.2 subtracted from 11.3 is 10 cents. So we did the math correct. We connect the dots with the demand curve. We label the y-axis price, we label the x-axis quantity, and we label the demand curve D. Now, we also label this diagram Big Mac demand. Moving from this point down to that point is a movement along the demand curve. Demand does not rise in this situation. Quantity demanded rises because the price fell. Okay, if demand of a good increases when income increases, the good is called a normal good. So for this particular individual, that's the case. Notice the price remained constant at $2.30. That's holding everything else constant. The only thing that's changing here is income is rising, which shifts the demand curve to the right. As a result, quantity demanded rises too. So in this scenario, quantity demanded rises and demand rises because price is constant. Now, if this person eats 90 Big Macs a year, no matter what, the most they're willing to pay when their income is low is $2.30 per Big Mac. Now, when their income rises, you can think of the demand curve, again, as the maximum price consumers are willing to pay for a given level of scarcity. If this person continues to buy 90 Big Macs a year, well, now the maximum price they're willing to pay is closer to $5. So when income rises, this person's maximum willing to pay rises too. So when you hear people say that a monopolist can charge whatever price it wants, that's untrue. The monopolist can charge up to the demand curve, which is why monopolists advertise to consumers. They want to raise your maximum willingness to pay. Now, for other consumers, Big Macs are inferior goods. That doesn't mean Big Macs are bad. It just means for other consumers, when their income rises, their demand shifts in. Okay, for this consumer, the price is still $2.30, but when this person's income goes up, instead of buying Big Macs, this person's going to Outback Steakhouse and buying a filet mignon. Now, if the price of McDonald's fries falls, right? If the price of Big Macs or the price of fries is falling, the quantity of fries is increasing. So as you buy more fries because the price fell, you're inclined to buy a Big Mac with the fries. That's why McDonald's has value menus. That's the economics of value pricing. So this triggers an increase in demand because the price of Big Macs was held constant. McDonald's only lowered its price of fries. It did not lower the price of the Big Mac. As a result, you buy more Big Macs when you buy more fries. Big Macs and fries are complements. Now, the price of a Burger King Whopper falls. Imagine there's a demand curve here. If the price of the Whopper falls, then you're going to buy more Whoppers. So if you're driving into town to go to school and you're going to stop at McDonald's to get a Big Mac, you look over the Burger King sign that says 2 for 1 Whoppers. What are you going to do? You're not going to go to McDonald's, so you're not going to buy as many Big Macs when this happens. You're going to buy more Whoppers. So Whoppers and Big Macs are considered substitute goods. And notice that the price of Big Macs was held constant because ceteris paribus, holding everything else constant. We change one thing at a time. The price of Burger King Whoppers falls. That means we're going to buy fewer Big Macs. The low carbohydrate diet craze might have changed how people felt about eating foods high in carbohydrates and calories. And since Big Macs have 3 slices of bread, then people are not as inclined to buy Big Macs. They're avoiding things with carbohydrates in them like bread. So in this scenario, the demand for Big Macs would fall. The price is constant, so quantity demanded falls from 90 to 75 because the demand fell. If the population increases, then there are going to be more people in the economy, and some of them are going to eat Big Macs. So this increases demand as well. Price again remained constant, $2.30. Quantity demanded rose when demand rose. A supply curve is analogous to a demand curve, and we can call it supply. It shows the quantity of a good that firms will produce at alternative prices holding all else constant. Quantity supplied is the amount of a particular good or a particular type of good firms will want to produce at a given price holding all else constant. A movement along a supply curve is a change in quantity supplied that occurs when its price changes, holding all else constant. So quantity supplied corresponds to a point on the supply curve, and if the price of that good rises, quantity supplied rises. Supply is held constant in that scenario. The law of supply is the economic principle that says the higher the price of a good, the larger the quantity firms wish to produce, holding everything else constant. We're going to test this theory by asking questions. You have an old oil well in Mississippi which produces 10,000 barrels a year. There are 9 other people in the area that have identical oil wells. How many barrels of oil will you pump out of the ground if crude oil prices are $15? How many barrels of oil will you pump out of the ground if the crude oil price is $115? Well, before we answer these questions, or ask these questions of these individuals, firms are interested in maximizing profits. And unit profit is the difference between unit price and unit cost. The unit price initially is $15 a barrel. Suppose the unit cost of pumping that oil out of the ground is $50. The unit profit would be 15 minus $50, which would be a negative 35. Nobody in Mississippi owning an oil well is going to turn on that oil well when the unit profit is negative 15. So individual 1 does not turn on the well. However, if the price jumps to $115, now the unit profit is 115 minus 50, or $65. So of course, individual 1 is going to turn on the well and pump 10,000 barrels a year. Individual 2 will do the same thing, etc., etc., etc. Now here we have 10 individual firm supply curves. Like we did before, we're going to aggregate the supply curve. Only now we call it an industry supply curve, not a market supply curve. The industry supply curve is the sum of the quantities at given prices. So the price of 15, quantity supplied for the industry is 0. At $115 a barrel, quantity supplied for the industry is 100,000 barrels. So according to our data, when the price is low, 0 is produced. When the price is high, 100,000 barrels is produced. We're going to fit a supply curve to these 2 points using point slope equation. The slope of this line is the rise over run. When the price was 115, the quantity supplied is 100,000. When the price is 15, the quantity supplied is 0. So the rise is $100. The run is 100,000 barrels of crude oil. So the slope is 0.001. We can pick either point. We picked the one where quantity is 0. We plug in the quantity and the price. The price is 15, quantity supplied is 0. We simplify, and we get the supply curve for the equation. Or we get the equation for the supply curve. Okay, so now let's double check and see if we did it right. If we plug in 0, we should get 15, and sure enough, we get 15. Plot the point. Now plug in 100,000. Well, we should get $115 per barrel. Sure enough, because 100,000 times 0.001 is 100, and 100 plus 15 is 115. Well, we did all the math correct. So now we plot the line and label it supply. We label this crude oil supply. Now moving from this lower point up to this higher point is a movement along supply. Now, because the actual line didn't change the location, we cannot say that supply increased. We can say that quantity supplied increased because the price went up. Now let's look at corn supply. If you're a wheat farmer and the price, or you can also grow corn too, so you can either grow corn or you can grow wheat. If the price of a related good like wheat falls, then you're probably not going to grow wheat. Now, remember, ceteris paribus. When we drop the price of wheat, we're going to hold the price of corn constant. Okay? So the price of wheat falls, it's no longer profitable to grow wheat, so the farmer grows corn instead. So the farmer increases the quantity of corn it's going to supply. And because the price is being held constant, the supply curve increases. What about TV supply? If the price of an input to production, say wages, falls, supply of TVs increases. Now, why is that? Well, remember that the supply curve is a firm's marginal cost curve. So if wages are falling and we hold quantity constant, that means marginal costs go from here down to here. Okay? Now with price held constant, that means quantity supply goes from 1.15 million to 1.4 million. So supply increases. What about McFlurry supply? Well, if technology improves, for example, if you compare how a McFlurry is produced versus how a Blizzard's produced, a Blizzard, you have to use a metal sleeve to protect the cup from the metal blades of the stirrer. Now, if McDonald's used that technology with 10,000 stores, every time they took a McFlurry off that machine, they'd be leaving behind product on the stirrer, and then when they pull the sleeve out, they would leave behind maybe an ounce of product on the sleeve, the metal sleeve. And then on top of that, you have to clean that metal stirrer, and you have to clean the sleeve. So there's a labor cost, and there's a cost associated with wasted product. So what did McDonald's do? McDonald's engineered a spoon that snaps onto a machine that allows a spoon to become the stirrer. They also engineered a lid that curves up to hold the product in. So there's no cleanup. After the McFlurry is stirred, you unsnap the spoon from the machine. You hand the stir/spoon to the customer with a McFlurry, nothing to clean, and no wasted product. So that lowers the cost, the marginal cost of production. So if we hold quantity constant, the marginal cost of producing a McFlurry goes down. If we hold the price constant, that represents an increase in supply. Now, what about health insurance? There was a lot of debate over health insurance a couple years ago, and part of the health reform bill, Obamacare, the Affordable Care Act, part of it was that government's mandating that health insurance companies cover pre-existing conditions. And I'm claiming that reduces the supply of health insurance policies. Now, why is that? Well, mandating that insurance companies cover pre-existing conditions is like the government mandating that home insurance policies cover homes that were knocked down by tornadoes. So if homeowners know that they can buy a homeowner's insurance policy, tornado insurance, after their home is knocked down by a tornado, well, that's a pre-existing condition, right? The home is sick. What are homeowners going to do? They're never going to buy tornado insurance. So the only people that end up buying tornado insurance are after their homes are knocked down. So that will bankrupt an insurance company because the only people that are buying tornado insurance are the ones where their homes are knocked down. And that'll be the same case in healthcare. If pre-existing conditions are covered by law, then people, rational thinkers, will simply not buy health insurance until they're sick. So then you get a situation where only the sick have health insurance. And that will bankrupt a health insurance company. Now the government knew this, which is why they also at the same time mandated that people, Americans, buy health insurance. Okay? So how does this affect the health insurance market? Well, the first mandate decreases the supply of health insurance policies because the marginal cost of supplying those health insurance policies drives up the marginal cost. And we've already seen many insurance companies get out of a certain type of insurance in some states. Now, that's not the whole story. Remember, government anticipated this and, as a result, required all Americans to have an insurance policy. So imagine there's a demand curve here initially. So if we just look at this first mandate that health insurance companies have to cover pre-existing conditions, that's going to drive up health insurance premiums. But then government comes in and says, well, everybody has to have an insurance policy. Well, that obviously is going to drive up demand, right? Forcing people to buy something means there's going to be more demand for that product. So demand is going to be out here somewhere, okay? So not only does the price of health insurance go up because pre-existing conditions are now have to be covered by insurance policies, well, the price goes up again because demand is going to shift out. And we all knew this because Dick Durbin on the Senate floor, while the debate was going on, said to the effect that people that think that the cost of health insurance is going to go down as a result of this bill are mistaken. He actually predicted the price of health insurance to rise as a result of this bill. And that's exactly what's going on. And he was a Democrat in favor of the bill. Okay, now let's talk about the law of supply and demand, which states that in a free market, the forces of supply and demand generally push the price toward the level at which quantity supplied equals quantity demanded. So we're going to use the two equations below to demonstrate this. Now this is a supply curve because the slope is positive. And the supply is a positive relationship between quantity and price. This is the demand curve because the demand curve is the relationship between price and quantity demanded, and that relationship is negative. We have to graph both these lines. In order to graph both these lines, we need 2 points. So we're going to plug 100 million gallons of gasoline into the demand curve for gasoline. And when we do that, we get a price of $6.10. We're going to plug 500 million gallons into the demand curve. We're not literally plugging in 500 million. The units are in millions, so we're only plugging in 500. So we plug 500 into the demand curve and we get a price of $1.10. We do the same thing in the supply curve. We plug in 300 and we get 30 cents for a price. We plug in 500 and we get $5.30 for a price. So now we're going to plot these 2 points. So when the quantity demanded was 100, the price was $6.10. When quantity demanded was 500, the price was $1.10. We connect the dots and we have the demand curve. When the quantity supplied was 300, the price was 30 cents. When quantity supplied was 500, the price was over $5. We connect the dots, we label that supply curve. Now we want to compute the equilibrium price. Well, the equilibrium price appears to be about $2.50. And quantity supplied and demanded look to be the same, between 375 and 400 million gallons of gasoline per day. So how do you compute the equilibrium price and quantity of gasoline? Well, remember that the equilibrium price is the price such that quantity supplied equals quantity demanded. And if quantity supplied equals quantity demanded, then the price on the demand curve equals the price on the supply curve. So that's why we set the demand curve equal to the supply curve. We're assuming the prices are the same. Now, when the prices are the same on the demand and supply curve, the quantities are going to be the same. And that's the only point on those two lines where that is true. So that's why we X out demand and supply. Now we add 7.2 to both sides, and then we add positive 0.0125 Q star to both sides, and we get 14.55 equal to 0.0375 Q star. And we divide both sides by 0.0375, and we get 388. Remember, it looked like something between 350 or 375 and 400. It's 388, and that looks about right. Now this isn't just 388. The units are millions of gallons per day. Now let's figure out what the price is. The market clearing price, or the equilibrium price. We plug this quantity into the demand curve, and we get $2.50, exactly what we expected. We plug this quantity into the supply curve, and we get exactly what we expected, $2.50. The fact that these two are equal is a result of assuming that this equals price, and this equal price. So when we set them equal to each other, we're assuming the prices are the same. So these two prices should be the same. Okay? So the equilibrium price is $2.50, and the equilibrium quantity is 388 million gallons of gasoline per day. And at this price, we say the market clears. Now, suppose the price was higher, right? Suppose the price was $5. Well, then people would not want to buy very much gasoline, but firms would want to sell a lot of gasoline. So they'd produce too much. And when firms produce too much, then we have like an excess inventory situation or a surplus. And whenever there's a surplus, like surplus brown polyester pants, what does a clothing store have to do? Well, they have to run a sale, which is another way of saying they lower the price. Now, if the price is too low, then consumers will want to purchase a lot of gasoline, but firms won't supply very much. In this situation, we have a shortage. And a shortage in gasoline markets is represented by long lines at the pump. And so what consumers do is they bid the price up, much like in the movie Jingle All the Way with Arnold Schwarzenegger and Sinbad. Sinbad and Arnold Schwarzenegger went around trying to find people that had purchased that doll for their sons, and they were trying to bid the price up so they could take the doll home to their sons.